Welcome back, focused learners, to another deep dive. Today, we are opening up something absolutely special. Consider this explainer your exclusive VIP access straight into the Cambridge Examiner's secret grading rubric. We are tackling a topic that is an absolute cornerstone of the Mathematics 9709 AS and A-level syllabus, differential equations using initial conditions. Now, I want you to think of this exam like learning to play chess as a grandmaster. You need to think 5 moves ahead. We are going to anticipate the examiner's exact next mental move before you even pick up your pen to write down your first equation. We're talking about mastering the strategy behind the math. Okay, let's dive right into this.
I want you to really think about this core question. Why do students consistently lose marks on differential equations using initial conditions? Listen, this isn't some obscure niche topic. This appears in absolutely every single examination series. It's guaranteed. Yet every single year, thousands of students walk out of the exam hall feeling incredibly confident that they isolated and solved for why, only to find out on results day that they dropped crucial grade-defining marks. So what is the invisible trap they are falling into? Well, let's look at 2 classic types of students I see all the time. Let's call them Alex and Sam. Alex is what I call the overloader. Alex will look at a differential equation and just start brain-dumping raw math facts, writing down every integration rule they can remember without any real analysis of the specific problem in front of them. Then you have Sam. Sam gets nervous about the clock, rushes through the prompt, completely misses the specific command word requirements, and forgets to apply the initial conditions in the required format. Both Alex and Sam fall into the exact same trap. It all comes down to a fundamental disconnect between just knowing the raw math facts and actually demonstrating the step-by-step analytical processing that the examiner is desperately searching for in your paper. To fix that disconnect and get you those top marks, we have a crystal clear roadmap for today's session. First, we'll cover the core theoretical principles. Second, we'll break down the standardized sequence. Third, we'll look at the top 3 examiner warnings. And finally, we will show you exactly how evaluating like a top scorer completely changes the game.
Let's start with Section 1, Core Theoretical Principles.
When you sit down for your 9709 mathematics exam, you have to remember that Cambridge's academic benchmarks prioritize analytical depth over superficial breadth. They don't just want the final answer. They want logical, structured reasoning. Look at the direct comparison we're highlighting here. On one side, the standard answer treats the differential equation as an isolated bubble. The student just integrates, plugs in a number, and moves on. But the top-scoring answer? That's a completely different story. According to the principal examiner reports, candidates who reference cross-topic connections achieve significantly higher marks. Examiners absolutely love it when you show that you understand how the entire syllabus fits together. For example, when you are solving a differential equation and you need to separate the variables, are you recognizing that you might need to use partial fractions from your pure math modules to actually perform the integration? Or what if it's a mechanics problem? Are you connecting the initial conditions of the differential equation to a kinematic scenario, understanding the precise relationship between velocity, displacement, and acceleration? The top scorers view the mathematics syllabus as an interconnected web, not just a rigid checklist of isolated topics. And speaking of hitting those top scores, before we continue, subscribe to our YouTube channel Ace the Exams at acetheexams_IGCSE to excel in your Cambridge examinations. Click that subscribe button and hit the bell icon right now. So how do we build that interconnected web? The theoretical architecture of this exam actually rests on 3 distinct cognitive domains: knowledge and understanding, application, and analysis. Let's break that down. Knowing the precise definition of an initial condition, like knowing that when the problem says initially, it literally means time t equals 0, giving you a specific starting coordinate, that's just your base level knowledge. Taking that coordinate value and successfully plugging it into your integrated equation to find your constant of integration, usually labeled as c, that is application. But analysis? Analysis is understanding the causal relationships. It's understanding why that specific constant shifts the entire graph of your equation up or down, choosing the one exact unique curve out of an infinite family of curves that correctly models the specific physical scenario described in the question. When you hit that level of analysis, you are thinking exactly like the examiner.
Which brings us to Section 2, the standardized sequence. How do we systematically translate that deep analysis onto paper when the exam clock is ticking down and the pressure is on? We need a practical, bulletproof exam strategy. Here is the exact 5-step procedural framework you need to apply to every single differential equation question you ever face. Step 1, deconstruct the question. This is where you actively decode the command words. What are they actually asking you to show or prove? Step 2, extract relevant data. Pull out those initial conditions immediately. Write them down clearly, like x equals 2 when t equals 0.
Step 3, select the analytical framework. Ask yourself, is this a separation of variables problem? Step 4, execute with clear notation. This is where you do the algebra and the calculus, and your notation must be flawless. Step 5, present with correct terminology. Your final answer needs to be formatted exactly how the command word demanded. I challenge you right now, create your own memory hack using the first letters of these steps, D, E, S, E, P. Deconstruct, extract, select, execute, present. Literally write that acronym at the top of your very next past paper to force your brain to structure your answer perfectly. And here is exactly why that 5-step sequence is so vital. This is the method mark strategy. This is the absolute secret weapon of high-achieving students. You see, examiners award you marks simply for demonstrating the correct analytical process, even if you make a silly arithmetic error at the very end. In the Cambridge grading scheme, you earn points by systematically demonstrating procedural steps. This proves your process knowledge. Let's say your final numeric calculation goes slightly awry because you dropped a negative sign. If you explicitly show yourself substituting the initial conditions into the integrated equation to find the constant, you secure those method marks anyway. In the examiner's eyes, this clear, systematic processing is just as critical as the final numeric answer. They want to see your brain working on the page. And if you want to see your grades skyrocket, stop scrolling, subscribe to our YouTube channel, Ace the Exams at acetheexams_IGCS to excel in your Cambridge examinations. We've helped thousands of students improve by 2-3 grade boundaries. Join them right now by subscribing to acetheexams_IGCS and turn on all notifications so you never miss our weekly exam strategy sessions. Moving on to Section 3, the top 3 examiner warnings. These are the major pitfalls you must avoid. I am pulling these warnings directly from the senior and principal examiner reports. These are the specific, repeated pitfalls that constantly trap candidates year after year. First, confusing cause and effect. This incredibly common mistake happens when interpreting the rate of change. Students mix up which variable is dependent on the other. They write dx by dt when they should be writing dt by dx. You have to clearly define what is actually changing with respect to time. Second, forgetting to check format and presentation. You genuinely wouldn't believe how many method marks are lost across the world simply because a student didn't write +c immediately after integrating, or their mathematical notation was so sloppy that an integral sign looked like an S, and the examiner couldn't follow their logic. Your presentation is your communication with the examiner. And third, providing non-contextual generic answers. I cannot stress this one enough. This is the ultimate mistake that consistently separates the A-grade students from the average ones. I really want to urgently underscore this point with a massive examiner alert. The absolute classic mistake is providing generic answers that are not specific to the given context. Listen to me carefully on this. If a differential equation models population growth, or the cooling of a liquid, or chemical decay, and the question specifically asks you to interpret your mathematical results, you absolutely cannot just write down x increases as y increases. That will get you 0 interpretation marks. You must explicitly state the context. You need to write, the population of bacteria increases as time increases, or the temperature of the liquid decreases over time. You have to link every single analytical point directly to the physical scenario given in the prompt. Do not leave your math floating in a vacuum. Give it real-world meaning. Finally, let's look at Section 4, evaluating like a top scorer. Once you have solved the differential equation and you found your particular solution using those initial conditions, your job isn't quite done yet. Top-scoring candidates utilize what we call a deconstruct, solve, evaluate, problem-solving loop to secure absolute maximum points on the toughest questions. Let's break down how examiners view your answers through this assessment framework table. At the base level, we have descriptive. This is basic element identification, like spotting the initial condition values in the text. Moving up, we have analytical. This is executing your systematic processing, properly separating the variables and doing the calculus. But the highest order assessment objective, the peak of the mountain, is evaluative. This demands checking your final answer for reasonableness. Does your final equation actually make logical sense given the initial conditions? For example, if time approaches infinity in your model, does your predicted population level off at a realistic carrying capacity, or does your math say it explodes to an impossible infinite number? Evaluating alternatives, analyzing asymptotes, and questioning assumptions, that is where true mastery lies. I want to read this exact quote from the Cambridge source material because it is incredibly powerful. Top-scoring candidates demonstrate evaluative thinking by questioning assumptions, considering different perspectives, and justifying decisions with evidence.
This is the ultimate mindset shift you need to make. You are not just crunching numbers to solve a math problem. You are building a rock-solid, evidence-based argument that your solution is the only correct one. And you are justifying every single step of that argument with perfectly structured, clear mathematical notation. You are proving to the examiner, beyond a shadow of a doubt, that you understand exactly what the equation represents. So let's do a rapid, high-energy recap of our examiner's playbook today. First, you must master the 5-step standardized sequence: deconstruct, extract, select, execute, present. Make sure you are structuring your answers to hunt down every single one of those method marks. Second, avoid those generic answers like the plague. Always tie your final solution back to the specific, real-world context of the question. And third, leverage those cross-topic connections to demonstrate deep, grandmaster-level analytical understanding. Now listen closely. Students who implement these mathematics strategies see an average improvement of 2 grade boundaries, but only if they practice consistently with our weekly videos.
I want to leave you with this provocative question to carry directly into your next study session. Which cross-topic connection will you actively look for in your next differential equations past paper? Will it be kinematics? Will it be partial fractions? Think like a grandmaster. Anticipate the examiner's moves and apply this structured strategy immediately. Here's your final reminder. Subscribe to our YouTube channel, Ace the Exams, at acetheexams_IGCSE to excel in your Cambridge examinations. Subscribe right now to acetheexams_IGCSE and click that bell. Don't let another exam pass you by. Drop a comment below with your target grade for mathematics and the biggest challenge you're facing. Our team responds to every comment. Like and share this video with a study partner. Ace the Exams. Your Cambridge success starts here.